Hi, my name is Jeff Bean. I'm responsible for the Verified Integrations program at Confluent. In my presentation, I'm going to talk about ScyllaDB, event-driven architectures, and Confluent platform. Hi, everyone. My name is Jeff. I run the Verified Integrations program with Confluent. So I'm responsible for all of our sources and sinks that feed into Apache Kafka and run out of Apache Kafka, but those that are supported by our partners like Scylla. What I'm going to do real quick today is I'm going to cover Apache Kafka on the quick. I've got about 4 slides just discussing what Kafka is, in case you've kind of been hiding under a rock, but you're afraid to admit it, because you've been hearing Kafka talk a lot, but you don't really know what that is. So I'm going to talk about that a little bit. But then I'm going to get into Confluent. I'm going to talk about the Schema registry. I'm going to talk about the Kubernetes operator with Confluent and Confluent Cloud. I've reordered the slide here a little bit, so then I'm going to talk Kafka Connect and KSQL and the event streaming database. I don't know if you saw the keynote this morning where they called out the Jay Krebs quote that all companies are becoming software. That came out of the Kafka Summit that we had last month, and specifically the event streaming database announcement. So I'm going to double click on that and go into that in a little more detail. And then we're going to talk about Confluent and Scylla and what that looks like now and what that might look like in 2020. So first, Apache Kafka. What is it? It's basically, at a high level, it's a pub-sub messaging system, right? You've got writers writing into a Kafka cluster, readers coming out of it. However, the data is stored locally on a cluster of brokers, and those consumers subscribe to topics and they read from it. However, it's not just pub-sub. Pub-sub has been around for a long time. I know I've been in the big data business for about 8 years, and when Kafka first came out, it just kind of looked like a message queue. And why is a message queue important, and how does that matter? Message queues have been around forever. Kafka is modern and distributed, and those things matter. So think about the scalability of a Hadoop or another big data system, of file system, hundreds of megabytes throughput, many terabytes per server, commodity hardware, linearly scalable. Add more nodes to this in order to get more capacity. Add on to that the guarantees of a database, strict ordering. So an event comes in, no event's going to come in before that, so events are going to come in after that, and it's going to persist. But this one, I think, is really the most important trait about Kafka, and it's really underappreciated until you've had a chance to work with it for a while. I can reset and rewind to any point in that stream. And that's just not one client doing that. Every client can do that. So I can have client A playing from the head of the stream, client B working with persisted data, and client C, D, and E somewhere in the middle. And all of these clients can be different applications in this world of software eating itself, right? So this is why Confluent's slide, I've actually omitted this slide because it's become kind of cliche, but this is why we have Kafka in the middle of what we call an event streaming architecture, right? Events can come into it, and then all the consumers can read from those events on their own timeline and in their own way. This is replicated, fault-tolerant partitioning, elastic scaling, right? In order to do this, though, we need to have other components, and these are components that are in Confluent platform, one of which is called Schema registry. If I have 2 applications, right, one application and 2 applications, and they're decoupled from each other, they're not reading and writing data to each other, but they're communicating via this Kafka topic, they need to know the schema of the data that they're working with, right? And if you imagine this world where App 1 and App 2 were developed in isolation from each other, brought on to Kafka at different times, they might have different schema. They might have different expectations. And if that schema changes, how do I communicate that change? So we have a centralized schema registry for this. It allows clients to register schema with that registry, and that data is serialized in Avro. And those Avro schema are then versioned over time, and it becomes a contract so that consumers and producers can actually understand each other and are guaranteed to understand each other when they're reading and writing to Apache Kafka. So that's a big part of Confluent Platform. Another big part of Confluent Platform is the REST proxy. If I have a non-native Kafka app that speaks REST, or if I'm outside the firewall, how do I integrate that with Apache Kafka? I have a RESTful interface to a Kafka cluster. I can communicate via HTTP, and I can simplify message creation and transformation. We also have a similar thing for MQTT, for IoT use cases, right? So if I connect IoT data sources to gateways, and then I can read that in to the MQTT proxy, which will then serve to Kafka brokers. When I talk about Confluent Platform, the thing that confuses me here a lot is I'm used to thinking on-prem or in cloud, right? You're either managed on-prem or in cloud. But actually, most of these, at least the two on the right, can be either on-prem or in cloud, right? Or you have the fully managed version in Confluent Cloud. What it's really about is how much DevOps do you want to perform here? Do you want to manage all your own deployment and versions and scaling and tarballs and so on? Or do you want to pay the experts Confluent to fully manage that? Or do you want something in between? Medium DevOps with Kubernetes, which is where I have a standard deployment environment that I can sort of maintain and manage across my own, across my infrastructure. This is the Confluent operator, and that was made available last quarter. This is really straightforward. It maps Kafka terms into Kubernetes environments. So I think in terms of nodes and pods and stateful sets, config maps, custom resources, and so on. We also support persistence. Right, so one of the things that makes Kubernetes difficult is state. And we support persistent volumes, AWS, S3, Gluster, GCE, persistent disk. And these are all managed in terms of nodes and pods with configurations and config mappings, load balancers, and so on. It's all automatically configured via YAML. Anyone else see that YAML engineer job description that was making the rounds on Twitter like last month or 2 months ago? I thought it was pretty funny. But I was on a support call just this morning where we were debugging a YAML file for Confluent operator. So it's a real thing. But either way, it's fully configuration driven. So this file is basically saying spin up this cluster, right? Give me 3 Kafka pods with external with a certain CPU and quantity and so on. OK, that's fine. So I can provision a cluster. I can make it secure. We can support SASL, TLS, automated configuration with trust stores, and so on. But I can also scale elastically. So here's a YAML file that adds 2 nodes to the cluster that I was just in. So I can use my Helm command to upgrade my cluster by adding 2 nodes. That will spin up 2 new brokers, rebalance, and execute that balancing plan and monitor it going forward. I can also do a rolling upgrade in the same way. So if I'm on 5.0, I want to upgrade to 5.1, new YAML file, upgrade to that, no problem. So that's Confluent operator. I can also do this fully managed in Confluent Cloud. So another great set of tweets I saw from Jay Kreps was basically saying that even you can have nice things, right? Confluent Cloud is a great place to learn Apache Kafka. I can go to confluent.cloud, give it my American Express card, and spin up a Kafka cluster. And if I'm new to Kafka, I can just start working with it that way. And that's really nice. But I can still use that same Confluent Cloud environment to take my application and my infrastructure all the way to production. So I can scale. I don't have to worry about managing this thing at scale, growing my cluster, doing how do I size this, how do I build a team to do this, how do I handle 24/7 ops, what cloud do I support, and so on. Right, so this thing performs. You can have nice things too. You can get a Confluent Cloud Enterprise up in 3 days or less, and you have infinite retention with great performance. High availability is supported in Confluent Cloud, different availability zones, 99.95% uptime. Right, so you can self-manage as well. So I can take Confluent Platform or Apache Kafka. I can spin it up in my cloud provider of choice, and I can manage that. That sort of handles this, right? But then there's all this Kafka-specific stuff and scaling stuff, which is, it's nice to be able to have an expert or an expert organization manage that for you. And that's what Confluent Cloud does for us. Moving on from Confluent or Confluent Cloud, how do I get data in and out of Apache Kafka? We have this consumer producer API, which is really low level. It's pretty good for applications reading and consuming events in real time. But if I want to lift and shift huge amounts of data, or if I want to do change data capture, if I have a heterogeneous infrastructure of data sources and sinks, Kafka Connect is a great framework for supporting that. So you can hook in JDBC, Tibco, MySQL, Scylla through the Cassandra connector, and get that going in and out of Apache Kafka. We actually maintain a marketplace of connectors. Many of them are supported and built by Confluent, but many of them are also supported and built by our partner ecosystem. And I'm responsible for this partner ecosystem. We're working with Scylla today on their connectivity. Once the data is in Kafka, How do you process it? How do you stream it? What can you do with it? This gets into the different frameworks of stream processing, and this gets into what Jay mentioned in our summit talk, where he talked about the event streaming database and different operations that you can do. You've got this sort of request response paradigm, which is what we're all kind of used to working with in environments, sort of the old school environment, where a human is interacting with a computer. They make a request, they get a response. Then you sort of have this batch paradigm where I take this batch and then I process it all in a batch and I wait and then I get an output. And then you sort of have this stream processing world. This is the new world where I have a continuous stream of events coming in and events coming out. And I still want to tune latency, I want to tune throughput, and I want to do aggregations, I want to do machine learning, I want to do AI on that stream as it's flowing. That's stream processing, and that's what we're trying to get into with Confluent. So if you take a look at the Kafka Consumer Producer API, this code and this code does the same thing, right? So we're leveling up, making it easier to do more sophisticated operations on data in a stream using SQL. Right, so in KSQL, basically what I'm doing here is I'm basically doing a select with a count and a group by, right? In KSQL, I can also define tables and streams. So I can have data in a Kafka topic, I can define a stream on that topic, or I can visualize that stream as a table, and then either have the version data moving forward or overwriting each other. So in a stream, how do I do it? I might say, create a stream of payments, here's my schema, use the all payments Kafka topic, user and format, right? In a table, create a table of credit scores based on my payment stream. Right? And then I have these two active queries that can be run, built on each other. And this becomes complex, right? I've got different stream processing architectures now. I've got connectors coming into Kafka. I've got consumers and producers coming into Kafka and coming out. I've got my stream processing framework where I've got these different projects that are out there. Those are distributed systems in and of themselves. Last month, we announced the event streaming database. This is a category of database. Nobody is going to be uninstalling Scylla or Cassandra or MongoDB and installing this event streaming database. It's a new kind of database for doing this kind of operation in one spot. So rather than have the stream processing engine separate, the connectors separate, and the state stores separate, bundle that together in its own thing, call it an event streaming database, and release that and use that to work with, do this very common pattern of application on Kafka. Right? So the idea is to be able to build a complete streaming app in one place simply. So I'm going to create, within my interface, I'm going to create a connection to a JDBC database, load that into a Kafka topic. Then I'm going to create a stream on that topic. Then I'm going to create a table on that stream by joining it with another stream and doing a tumbling window, 5-minute tumbling window. And then when this emits changes command basically makes that an active query, so it's always running. And then I'm going to do a select to actually pull data out, right? So the idea is that I want to do all this stuff in one spot without having to cobble together all these different distributed systems. And connectors are first-class components to this. I spent a lot of time talking to our partner ecosystem around, okay, you guys made this announcement of an event streaming database. How is that different than my database platform? How is it different than Scylla or Mongo or MySQL or anything else? And I think by having the ability to build a connector right into KSQL, it really illustrates that this is a different thing, right? We're making it easier for you to build your event streaming queries using the databases that you have, and using this as providing this as a first-class component. We have a web page called Kafka Tutorials. You can go to, just Google Kafka Tutorials. You'll see the best way to learn KSQL. It's really easy. How do I join a stream? How do I build a stream from a table? You get Docker images in there. You get the ability to sort of learn this in all these different ways, and then how to take it to production. So take a look at that. There is a talk tomorrow on Lookout that talks about how they use Scylla and Confluent together in AWS. I talked about Confluent Cloud. They use a self-managed AWS environment to do this, but they use Kafka Connect using the Cassandra connector to do what their talk is about, handling scaling device data to hundreds and thousands of devices. All configuration driven, right? So this is one slide out of that talk, right? This is how they configured Kafka Connect. No code for this. Load up the Cassandra connector, point it at Scylla, and go. There's another blog that Mahi wrote on the Confluent blog on using the MQTT proxy in Confluent, and he steps you through spinning up a Confluent cluster, spinning up a Scylla cluster, generating MQTT messages, and processing them. And in the future, take a look at the event streaming database. We're releasing that this month. Confluent Cloud today does not have terribly great connector support. You can read and write to S3 and AWS and your local, your cloud local storage. We're going to be expanding that ecosystem with both Confluent connectors and Confluent partner connectors. And we're also talking with Scylla about possibly producing a native ScyllaDB connector. Today we're working with the Cassandra connector. It works really well. It's used in production in lots of different places. But there might be a need for a shard-aware native connector. So we'll take a look at that as well. Lots of great places for more information. So we've got this blog on IoT. We've got the Lookout joint webinar, the talk tomorrow. If you're interested in Kafka Connect, there's an old blog entry that shows the simplest useful data pipeline with Kafka Connect. Gets you started from nothing and has you loading up data into Kafka from Connect. KSQL tutorials, kafkatutorials.confluent.io. Kubernetes operator tutorial, Vic Gamov, my colleague, did a great video on that. That's available as well. Confluent Cloud documentation, and the event streaming database, the keynote from Kafka Summit 2019. We don't really talk a lot about we don't really differentiate in that presentation the difference between an event streaming database and something like Scylla, so refer to this presentation for that. But that's a good one for context.